I'm very sure about this. Your math is better than mine. I'm 100% sure. Okay, the level of math you guys learn is so much more than me when I was undergrad. I'll tell you that. Okay. So you have values like this, 65 megapascal. Okay, right, and they start forming equations. Okay, like they start forming the equations. Okay, and to be frank, I don't know what these equations are all about. I don't know. Okay. And then they have a stress max down here. Then you all of a sudden they have something called reject down here. Okay. And then they do calculation like this. Okay. And then all of a sudden they have something like case number 2, right? And then they put this in 75 average. You see all these numbers, okay? Now, if you ask me what it means, I will tell you I have not a clue. Okay. I don't know what they are doing. And it's too much to figure it out. Okay. So I'm going to teach you, right, what I've been teaching. I'm going to apply what I've taught you. Okay. So that's a problem about user manual. Okay. They have a certain way of solving things. The user manual user have certain expertise that I don't have. I'll tell you that I don't have. Okay. So I'm going to solve this just applying what we learned. Okay. Nothing special. There's nothing special in this sauce, okay? In this soup, it's just plain Kung Fu Panda. I know, right? Right. So let's just apply Mohr Circle, okay? And when we apply Mohr Circle, everything comes to light, okay? So now we are going to look at this. So we know. So I'm going to label this my point X. This is my point Y, and over here is my point Z. Okay. So we are given that tau max, right, is equal to 75 megapascal. So regardless whether is it 2D or 3D Mohr circle, okay, the maximum allowable radius is 75 megapascal. Okay, maximum. I don't care whether in plane or out plane, it has to be the maximum. Okay, you cannot be greater than that. And then we are given that stress. So hold on. So once given this, right, we know that the maximum stress or the minimum stress is equal to plus or minus twice of tau max. Right. So this is equal to plus or minus 150 megapascal. Okay. So this is the diameter of the circle, basically. However, we have one anchor point. Okay, there's an anchor point that we see down here, which is our stress Z. Stress Z is equal to 0. Okay, period. Okay, stress Z is equal to 0. So over here, this is a material behavior. It's like we got this from a materials handbook. Okay, right? We got this. So this is what when you open a handbook, this is say what it should be this value. So now we start constructing Mohr circle. Okay, we start constructing Mohr circle. So this question asks us what are 2 possible value of stress Y. Okay, what are the 2 possible? Now this question is uploaded onto Avenue to Learn. Okay, so if you want, you can go to Avenue to Learn, download it, where I draw the circle, or I do my scaling. Okay. So this is I'm going to draw the full length, okay, because I have something to highlight. Okay, so this will be equal to I will take minus 200, 180, 160, 140, 120, 100. Okay, then we have minus 80, minus 60, minus 40, 20, 0. Tell me if I miss anything. Okay, it's too early to do things like that for me. Okay, so you have 20, 40, 60, 80, 100, 120, 140, I'm going to start at 160. Okay, 160. And we'll start at 160. And then we're going to have the shear. Shear is easy because the shear will stop at 75. We were given that information. Okay, so we're going to draw shear. Okay, so there's our shear. Clockwise, anti-clockwise, right? So 20, 40, 60, 80. I'm going to draw 100. Make sure the scales are the same in the x-axis and y-axis. Okay, if not, you don't get a Mohr circle. You get a Mohr over. Okay, minus 100. Right. So we're going to incorporate. Okay, we're going to incorporate. Okay, not incorporate. We're going to integrate material behavior into a Mohr circle. Okay, for this case. So we know, right? Based on material behavior, we know that the diameter or the maximum minimum stress will be plus or minus 150. The maximum shear is what? 75. So we're going to draw a operating boundary. Okay, we're going to draw an operating boundary. Okay, so operating boundary. So 150 and 7. I'm going to eyeball the 75. Okay, so this is our operating bracket. So what do I mean by operating bracket? Okay, our circle cannot touch this, cannot go the region where I'm shading now. Okay, if it touches, means you are going beyond the maximum allowable stress. Okay, so this is how we incorporate Mohr circle with yield strength. So our circle has to be what? Inside the box or inside the rectangle. It cannot go outside of the box or outside the rectangle. If it does, your structure exceed the maximum allowable, and it might go into plastic region, or it might fracture. Either one. Okay. So that's where I told you guys, right? You don't get this from textbook. They or solution manual. They just tell you they just will tell you like, okay, this is not okay. Okay, this is rejected, things like that. Okay, but what does this actually means? Okay, it's just drawing a box now. Okay, so we construct a box, right? If the circle go outside the box, that magnitude of stress is not possible for stress y. Okay, right? So next we construct Mohr circle. Okay, we construct Mohr circle. So if you look at the stress state, okay, let me copy this so you can see the stress state. Okay. All right. So we know that our x is at 150. Sorry, our x is 70. Okay, not 150. Eugene, come on. So this is 70. Right. So this is our stress x line. Right. So this is our stress x line. Right. And then our shear is at 40. So I'm going to draw the 40 all the way. Okay. So when the solution does the solution in the solution manual, how they formulate is they can visualize this in their brain, okay, in their mind. You know what? I can't visualize this. Okay, it's too early for me. Okay, and I'm not as bright as they are. Or I'm only more hardworking. That's about it. So this is our point X. Okay, that's our point X. So what the question gave us is also that the maximum shear is 75 megapascal. Okay, so our maximum shear. So that is the radius of our circle, as I mentioned to you, right? So that's the radius. So we have this point over here. So next thing we want to find is our stress average. Why we want to find our stress average? what they have given us, now this is just a sketch, okay? This is just a light sketch. So we are given this value now. I'm not saying that this is the right value, okay? We have to calculate it. Or we are given that the radius is equal to 75. Okay. So that's where we have to calculate we have to calculate the distance from here to here. I'm going to call it omega. So with this omega, all right, we have to find omega. So I'm going to write this down here, okay? We have to find omega to determine our stress average 1 and 2. Okay, so over here, let's say this is just a sketch. This is my stress average 1. Okay, and then we know the other possibility, right? The other possibility is this is our stress average 2. Right? Once we know we can identify our stress average point, then we can project it to the shear line to determine our stress Y. Okay, so I'm going to do this now. Okay, so omega is equal to what? So we know the radius, right? And we also know the height. We also know this distance, right? We also know this distance, right? So this distance is 40, right? So omega is equal to 75 squared minus 40 squared, right? So 75 squared minus 40 squared square root of the whole thing, 63.442 or 63.443. Okay, so from here we can find our stress average 1 and 2. So it's equal to minus 70, right? We know that it's from point X minus 70 plus or minus 63.443. Okay, so minus 70 minus 63.443 is at one point the stress average is minus 133.443, and the other one is 63.443 is equal to 6.557. Okay, negative. So we know where our stress average is. Okay, so I'm going to draw our stress average. Right, so one is over here. Okay, and then the other one is over here, 1.323. Right. So we have identified our stress average. Okay, so this is my stress average 1. And this is our stress, this point is our stress average 2. So once we have our stress average, then we can draw our, okay, then we can construct our stress Y. Okay, so stress Y, as you can see down here, okay, so this over here, one point over here will be our stress Y1. Okay, or I'm going to call it Y2. And then the other side, right, the other side is our Y1. Right, and you guys will say, oh, Eugene, Y1 is not allowed anymore. It went outside the circle, right? So now, let me draw where the center of the circles are. Okay, let me draw where the centers are circled. Plus, I will finish exactly at 9:20 today, okay? Or 10:20, sorry. So this is our, Eugene, come on. This is our stress average 1. This is our stress average 2. Right, over here is our stress average 2, right? And then if we look at where the point intersect, or where we intersect the y1 and y2, right? I'm going to draw another 2 lines. All right, so this distance from here to here, and then another one from here to here. So what I want to highlight is this: how do we calculate the stress in the y1 and y2? Okay, so if you look at this distance over here, so we know this distance, yes or no? We know this distance, right? And this distance, if I construct it properly, right, is also equal to this distance to the center of the circle. So if you know where the center of the circle is, if I'm going to draw this distance to where y is the same distance. Okay, I mean my scaling is not perfect, but okay, it's also equal to this distance over here. Okay, so when that's the case, now we know how to find stress y1 and stress y2. Okay, so we're going to, let me make this size. So stress y1. Okay, so you can see. Okay, stress y1 is okay. I'll do this. So stress y1 is equal to minus 133.443 minus by 63.443, right? Because it's on the left hand side of x, yes or no? Okay, so from here 133.443 minus by 63.443 is equal to minus 196.886. And the other one, stress y2, is you are going to take stress average number 2 minus 6.557 plus by 63.443. So this is equal to minus 6.557 plus by 63.443. It's equal to 56.886 positive. Right? And we know, right, from here we can see, right, we can see that point Y is not valid because it's outside the what? Outside the operating boundary. So you just put down here, not valid. Right? It's outside the box. Yes or no? What did I tell you about the box? It's the operating boundary, right? You cannot go more than that. Okay. So if that's the case, I will stop here and I'll carry on later at 2:30. Okay, I'll carry on later at 2:30. Thank you. Anyone, any question? I'll still stay behind. Okay.